Cool. This morning I promised a follow-up session on core data called Advanced Core Data, and it's actually not a lot of stuff to talk about, but I want to spread it out since the whole core data stuff is pretty complex in itself, and I didn't want to put too much information into one session, so I broke this out into a separate one. Basically just 3 topics I want to cover, and migration is going to be super short, so there are 2 main topics. The first one is concurrency, and the second one is how you can work with child and parent contexts and how that can be useful in your apps. Who here has worked with multi-threading before or knows what multiple threads are, such kind of things? Significant portion? Okay. So tomorrow actually we're going to have a lecture on threading on iOS and also threading concepts in general, so we'll dive in deeply, but the important part for this core data session is just to understand that some frameworks are very picky about how you use them in the context of multiple threads, and core data is one of them, so I want to point out some things you should be aware of when using core data together with multiple threads. So first, the most important thing is that you cannot use a managed object context for multiple threads. Each managed object context only works, in quotes, on the thread where you created it. The typical setup is that you have one context that sits on the main thread. The main thread is the one that does all of the UI updating, and it's the one that you use by default if you don't spawn another thread. That is where your main managed object context will live. And then you will create child contexts for background threads. Another important part about that is that managed objects can also not be passed between different threads. So a typical scenario where you would use threading is when you want to download something in the background. Let's say you download music videos. You would do that in the background, and then you want to store objects into core data. Then you cannot pass these objects that you created on a background thread to the main thread. If you access them from the main thread, you'll result in crashes or undefined behavior. Yep?
I want to assume that the way you do it is save the disk in one thread and then read from disk in another.
It's similar, but we're going to talk about it later. So that's an important part. You cannot pass in between threads. So if you want to send a managed object between 2 threads, what you have to do is you have to take the managed object ID, which is basically just an identifier for that object. You pass it to the other thread, and the other thread has to talk to its own managed object context and fetch the object again. So it basically has to fetch it separately from core data using the ID that you pass along. So there are 2 different types of concurrency types that you can use together with your core data contexts, and I'm going to touch on them briefly. The one that I already mentioned is the NS main queue concurrency type. So when you create a managed context, you have to provide one of these 2 types, and per default you're always going to have one managed object context on the main thread. That's what I just said. It's basically the same thread that updates the UI. And that one will have the main queue concurrency type. And you always only have one of that type because your entire application will only have one main thread. Then if you want to work with background threads and you want to create additional threads that work with core data, on each of them you're going to create a context that has the NS private queue concurrency type. So these are ones that can also be accessed from background threads. And I'm going to show how you can work with them. So if you assume this code here runs on a background thread, I hope you maybe have the slides open because it's hard to read. But assume this here runs on a background thread, you get some JSON data that you want to store to the database, and you want to do that within this thread here, then what you would do is you create a separate NS managed object context, and you provide it with the private queue concurrency type. That's the type you use for anything that happens on a background thread. Then what you do is you assign a parent context, and the parent context would be the managed object context that lives on the main thread. We're going to talk about parent-child relationships on the next slide. And then if you want to do any operations on this context, what you have to do is you call on the private context perform block, and then you pass in a piece of code, and that piece of code will be executed inside of that context. So that's just in general how you would use a separate NS managed object context on a background thread. Now when you save that here, then it's only saved within that private context that belongs to this thread, and you would separately have to save the main context one. You're going to see that on the next slide. That's in general, important context when working with, concept when working with core data is the concept of child and parent context. I try to make it more understandable by drawing something. I hope it's more or less useful. So here's the situation that I just had on the slide. We have a child context, and that can be, for example, on a background thread. Then we have a main context. That main context is part of every core data app, and that main context lives on the main thread. And the main context is the one that is directly connected with the persistent store. So now if you're on a background thread and you save a change, then what happens is it goes from this child context into the main context. So the unsaved changes go from here to here. When you save this here, but you can see that they're not stored in the database yet. They just moved up to the parent context. At this point, you have the unsaved changes in the parent context. If you save the parent context, then because this one here is already the root context and doesn't have another parent, then the changes go into the database or into your persistent store. So basically you have to save two different contexts to actually get these changes to be saved persistently. Question. So the question was, is one of them considered private or main queue? So this here is the one that lives on the main thread, and that one is always the one that's going to have the main queue concurrency type. That basically says this one always runs on the main thread, and that's always reserved for this blue one here. Any child context could also run on the main thread, but if you have on a background thread, then it has to have the private concurrency type. You don't necessarily want to save changes on the main thread, but you have to go through the main managed object context because that is the only one that is connected directly to the persistent store. So typically you only have this one context, and if you have additional context, then they have to be children of this main one, and you always have to go through the main one to actually save it to disk. Make more or less sense? We're going to talk about a second example in a second. Yeah?
Which context calls save?
Both contexts call save. So first you call save here, then you have this scenario, then you call save on this one, and then it's stored. And one use case is doing this for background thread and foreground threads, so that's what I just talked about. If you have any kind of background thread, you have to use a second managed object context and use this kind of pattern that I just showed you. But it's actually also useful if you want to create an app where the user maybe has some temporary changes that they don't want to necessarily store into the database. What you can do in such a case is you can say, I take my main context and I'm going to create a child context. Then I'm going to make all the changes in the child context, and at the end, when all the changes are done, I'm going to give the user a chance to say, okay, I want to save these changes, or I actually just want to discard them. Then if you hit save, the changes would actually go into the main context. If you hit discard, then the changes would be gone forever, and they wouldn't leave any traces for any other part of the application. So maybe to go back to the image, just to show you this. This is used for a background thread, but it also could be any part of your application that wants to change data, but is not sure if the user is actually going to decide to save it or discard it in the end. Makes more or less sense? To some people it does. Any questions around this? Cool. Then migrations. I mentioned it briefly. Migrations are necessary whenever you change your data model. In core data, you get a lot of migrations for free. So any kind of migration that is very simple, for example, adding a field that wasn't there before and providing a default value for that is something that core data can do automatically. But you still have to create a new version of your object model file. So inside of Xcode, you can click onto the object model file, you can say create new version, and then you can modify your file. And if you only add fields, for example, then core data can perform what is called a lightweight migration, because it can infer what the new fields should look like, and it can simply add them to the existing models. Yeah, you have to be a little bit careful and read the documentation that will tell you which kind of things you can do with a lightweight migration, because there are a whole bunch of things that you can't. For example, adding a field that doesn't have a default value. Because if you add a field that is required, and you say, my user now also has to have an email address, and that wasn't necessary before, and you say the email address is a required field, then core data would not know how to add the email address to existing users that don't have that field. In such a case, what happens is when the app launches, your app will crash because it says that the data model that you have on disk is inconsistent with the one that the app expects. So that is something migration is a whole kind of big topic to read about separately. I suspect none of you will need it throughout this 2-year program, but if you actually maintain your app and change it over time, then migrations will be fairly important. But there's very good documentation on that. Cool. Summary. The managed object context and managed object classes are not thread safe, which means essentially you cannot use them across multiple threads at the same time. That means if you have any app that uses multiple threads that all want to talk to core data, you'll have to review these slides to understand how to set up the communication pattern correctly. And that is using a separate managed object context for a background thread that is the child context of the one managed object context that is on the main thread. And I also showed you that having a parent context and a child context setup can also be useful if you want to make temporary changes where you're not sure if the user wants to actually store them or not. And last, we talked briefly about migrations. I think the only important part there to take away is there is something called lightweight migrations. You should understand whether or not what the change you're making falls under such a lightweight one. And if not, then you have to learn a little bit more about how to manually migrate between different version models. Okay. There's actually a good write-up on both of these topics, so you can spend a lot of time reading through there if you need it. Thanks.